All right, welcome folks to this weather and climate virtual office hour. There is some weather to talk about in the short term in California and the broader West, so that'll be the focus of today's conversation. Just want to remind everybody that this channel is sponsored by Reask, a climate tech company that's helping other entities rethink their extreme weather risk and exposure in a warming world. And as always, there's a link to them in the closing segment of the video. I also wanted to highlight that there is actually an event that is now live and ongoing, a 100-hour long live stream by, quite frankly, many of my colleagues in the weather and climate world, and arguably a pretty good sampling of some of the most prominent weather and climate scientists in the United States in this moment. I've actually included a link to this broadcast in the chat, and so I won't fault anybody if they end up heading over there during the live stream, although I will point out it is a 100-hour long live stream, 5 consecutive days, and it has just begun this afternoon. I will be participating in this live stream on Saturday evening, and you can find out more information regarding the exact timing of the different speakers on the event website. For my part, I will be offering perhaps a broader version of the kinds of conversations I typically have in these Weather West virtual office hours. So I'll be the only person out of all the dozens of speakers essentially offering a virtual Ask Me Anything session, as I have a few times on this channel. So where we solicit questions live from the audience and I answer them essentially without a lot of prior warning or prior knowledge of what's going to come up. So I'm so confident that people will ask interesting and relevant and thought-provoking questions that I'm happy to take that approach instead of having some prepared remarks, as many other folks have done. I was watching the stream a bit earlier today, by the way, and it's already been very interesting, a bit sobering so far today. A number of scientists filming the last hours of the NASA GISS laboratory in New York before it was officially shut down. They were literally kicked out on the live stream. The 2 former directors of the National Weather Service spoke, people who diverge very strongly politically and ideologically, and yet realize that in this particular moment they really don't have any fundamental disagreements about the horrifying absurdity of how things have been unfolding at the federal level. And to come this evening, a lineup of, I guess we call it primetime talks that are beginning now over there on the other live stream, including, again, a lot of my weather and science colleagues tonight, then again tomorrow night, again on Friday night, and then again, yet again on Saturday and Sunday night. So this is a 5-day long live stream. I'll be participating Saturday evening, so the 31st, the last day of the month. And I encourage you to join not only the live stream when I'll be on it on Saturday evening, I believe I need to double check the Pacific timing here, but I believe it's 5:30 Pacific time. Let me just make sure I'm getting that right now while I've got you. It's 6:30 Pacific time on Saturday the 31st is when I'll be offering my contribution to the live stream in real time. But also some really excellent science talks about various weather and climate topics, both related to what's going on with the federal government and not. Some of them are just pure science, people showcasing what they do and why it's so important. And again, some of the leading weather and climate scientists, the people who I greatly respect and whose careers I have followed through the years and whose papers I rely upon over some people who have had a career of 4 to 6 decades, depending on who's speaking. Longer than some of the other speakers have been alive. It really is a remarkable lineup of dozens and dozens of people. And again, it is a 24/7 live stream, so I don't even know who's filling the other time. There will be even more weather and climate folks there. So I think this is a really helpful way to engage, important way to show your support for weather and climate science in the U.S. And this is ostensibly a nonpartisan live stream and event. Now, that doesn't mean it's non-political. In fact, you could argue it's very political, but that's out of the unfortunate necessity of the moment where, unfortunately, weather and climate, both the science of, the practice of knowledge gaining in the field, but also the practice of basic weather forecasting and meteorology. So it's applied the manifestation in society at the Weather Service with NOAA, with day-to-day weather predictions, oceanographic predictions, tsunami predictions, all of these sorts of things that we rely upon for our safety and efficiency in day-to-day life. Also at direct risk, in addition to our research about these things. So if you want to learn more, I've talked about that plenty on this channel already. I will continue to do so as opportunities arise and as circumstances warrant. But for this week, head over to the other live stream, the 100-hour-long live stream staffed by dozens and dozens of my colleagues. I'll be on there Saturday evening, 6:30 Pacific time. Ask Me Anything session. Link is in the chat. I'll remind folks at the end of the session as well. So what I really want to talk about today on the California side of things in this live stream is the rather whiplashy period that's coming up. We're entering it now. Today is a much warmer day inland. It's not particularly hot at the coast, but as you go inland, it's certainly warmer than it has been. But the real warm-up and heat wave is going to be from later tomorrow into Saturday in many places. So this one's going to be centered more in Northern California and in particular across the interior of California, where some record-breaking temperatures even are possible in the Central Valley and in the foothills and mountains ringing the Central Valley in particular. So places like Sacramento and Redding could see some record highs. This doesn't look like a record-shattering heat wave by any means, so we have certainly seen more extreme ones, both in a season relative sense and in an absolute sense. But we will get pretty close to all-time monthly record May monthly temperatures in some areas like Redding and the northern Sacramento Valley, Friday into Saturday, and we will definitely see some daily record highs across a much more widespread region, potentially including Lake County and the parts of the Bay Area, as well as the Central Valley and the foothills. So it will be a notable heat wave, though it won't be particularly prolonged, because by late Saturday into Sunday, there will be a pretty rapid change in the weather back in the other direction. And as I'll show you with some weather maps, there will probably be a cutoff low pressure system as part of what's known as a Rex blocking pattern. I'll show you visually what that means in just a moment. That could lead to some isolated thunderstorms across parts of Southern California this weekend. Probably not super widespread, but also bears keeping an eye on. Before yet another swing early next week where a low pressure system slides southeastward across Northern California and the Great Basin and brings a whole different set of rather changeable and fairly dramatic weather conditions. So from potentially record heat in parts of Northern California Friday and Saturday to very windy and much cooler conditions by Monday and Tuesday, probably with at least a few mountain showers, maybe even some very high mountain snow showers at 10 or 11,000 feet. And at least the slight potential for some more widespread showers or thunderstorms, although that doesn't look super likely right now, before we swing yet again back in the other direction, speaking of whiplash, back towards potentially quite hot conditions, especially inland and in Northern California. So from very hot to much cooler and windy, and with some patches of maybe even some precipitation mixed in with some elevated fire weather, depending on where you are, and right back to heat again, all in the course of 7 to 10 days. Not typically what we see in June in this part of the world. So I think what I'd like to do is just start by showing some of the imagery. So you'll see my screen share in just a moment here. The infamous infinite mirror. Okay, so first I actually just wanted to start with where we are right now with western snowpack. as we head into late May. It is relatively late in the spring, to be sure, and snowpack, even in a typical year, would be rapidly on the decline as we get close to June. But what we're seeing right now is a pretty broad region of well below average late season snowpack. And this is notable partly because it was not nearly so below average in a widespread context earlier in the season. And let me just make sure that it's sharing what I intend to share here for a moment. Sorry, I just got a message from somebody that it wasn't quite displaying what was expected, but no, there it was anyway. Apologies for the tech trouble. So here's where we are with snowpack. This is a nifty new website from the Department of Water Resources in California, by the way. And let me bring up my drawing tool so I can scribble a bit. Or actually, I'll start with the west-wide map. What we've got right now, and this is updated as of, I guess that's yesterday. So this is quite up to date. I gotta change the, well, I'll leave the color of the pointer as red, even though it's the same color as a lot of what's on the map, which is to say there's a lot of red. So there's a big region of well below average, essentially nearly absent snowpack from central and southern Sierra, across the Great Basin, southern Rockies, into the Four Corners region. There's also a broad area of below, but not extremely below snowpack, sort of in the northern and central Rockies, so from Colorado up through western Montana, Idaho, western Wyoming. And then there's another region of well below average snowpack in the Pacific Northwest, so most of Washington and much of Oregon. The singular exception, actually, to below average snowpack late season, interestingly enough, is this atmospheric river corridor in far northern California and far southern Oregon that kept getting slammed from fall through late spring with atmospheric river after atmospheric river after atmospheric river. It wasn't a particularly cold winter in this region, but it was definitely a particularly wet one. And we can see that in the legacy of the snowpack. Now, granted, in some locations this is a slightly misleading number because the snowpack by late May is pretty low, so what's double a small number can be a very large percentage increase. But it is worth noting that this is the one region in the West right now that has above average late season snowpack, and virtually everywhere else it's really low or even essentially absent. And if we do zoom into California, I think this really tells the tale, since I like the distribution. You can kind of see this is both a traditional time series, that's the blue plot here, calendar month, how much snow is typically in California's mountain watersheds at a given point in the year. That's the blue curve. That's what you would see typically over the period of record. So that goes from 1990 through 2020. Again, as I've pointed out recently, it's worth noting that due to climate change, this typical distribution of snowpack is not what it was in the 20th century. We would have had a slightly longer snow accumulation and a slightly higher peak in the 20th century, looking something more like that. So it's the same general shape. We shave off 10 to 15% off the top. That's about how much the snowpack has reduced. But you can also see how in some cases this sort of results in a snow season that is shorter than it used to be. So we sort of are starting later in the year and melting out for the most part earlier than we used to. The reason why I emphasize that is we can kind of see that playing out in recent years. So last year, that's the gray curve here. And remember all the headlines about how last year had above average snowpack. Well, that was true at the peak of snow season. We did indeed have above the long-term average snowpack on a statewide average basis, although I'll point out again that due to the loss of snowpack over decades, the typical historical value would have actually been closer to what we got last year. But in any case, it certainly wasn't a bad snow year, near to above average. This year, which is the black curve, you can kind of see that the snow season sort of went in fits and starts, especially at the beginning. It actually started off pretty good, above average, and then flatlined for a while before improving once again. And the seasonal peak was very close once again to the recent average, showing near average snowpack year at the peak. But look at where we were for most of the snow season, early in the season below average, and then once again, since then, we've also been below average for the entire season. So we briefly peaked at near average, but look at where we are now. If we see the red dot here, I'm going to leave that on screen. I'll have to draw my dot. So this is where we are now as we approach June 1st. Now, granted, obviously we're in the time of year when snowpack declines rapidly on average. That's what you'd expect as you go from winter to summer. That's probably no surprise to anybody. But look at the rate of decline. We've actually seen both an early melt out to snowpack. This was in April and early May. And now a particularly steep snowpack loss in recent days, such that we are now, as we get close to June, closer to where we would typically be around July 1st. So you can kind of see on a statewide basis, as we get to June 1st, the snowpack conditions are going to look a little more like July 1st. And while that might not sound like a huge difference, keep in mind that typically on June 1st, we've actually still got a significant amount of snow water equivalent on a statewide average basis, at least in the historical average, around 6 or 7 inches of liquid equivalent water. So that's the equivalent of having 6 or 7 inches of rain stored in mountain watersheds as water on June 1st. But this year, we're on track to have less than 2 inches stored on June 1st. So that's actually a pretty big difference, because that's the water that helps us get through the summer months. Not so much from a water supply perspective, because even if that stuff melts early, as long as the peak was there, that water is still draining into rivers, lakes, and streams and reservoirs to a large extent. Not 100% of it, but most of it. But from a soil moisture perspective, it means essentially we're going to have a summer that's at least a month longer from the vegetation perspective, from a wildfire perspective, than would have been the case if we had snow that didn't melt till late July. But we're going to be there instead in early June, particularly because this heat wave this week is going to affect this region preferentially. So the snowpack accumulating region, I suspect that this black curve is just going to fall pretty close to zero over the next 5 days or so. And you can see that in general the snowpack is better in the north of the state right now than it is in the south. And you can see essentially in the southern Sierra, the snowpack is nearly gone at this point. Not sure why my pointer's changing color. I'll just sort of try and fix it at red. But anyway, that's where we stand in terms of snowpack, and that's one reason why there may be a more active fire season, as I've talked about in recent sessions, in higher elevation and forested parts of the West, including California, than we've seen in recent years. So in addition to having an active fire year at lower elevations, which was already looking pretty likely, this may expand into other settings where we haven't seen such active fire conditions in recent years. Okay, so I want to show some weather maps now. Here again, as I often show, is the European ensemble. So all of the members of the European predictive weather model averaged together. This is the 500 millibar geopotential height anomaly map, meaning essentially depicting in red colors regions where atmospheric pressure in the middle levels of the atmosphere is higher than it would usually be, blue being the opposite, lower than it would usually be, and the units are, in this case, standard deviations. So how relatively unusual it is. Once you start getting close to 2 or 3 standard deviations, that's a big deal, highly anomalous, very rare event. Well, as you can see, as we get into Friday into Saturday, we are seeing some of those darker red colors across portions of Northern California and the Pacific Northwest, up around 2+ standard deviations. And what this means is that this pattern is essentially on the verge of being something we haven't seen of this magnitude before historically. So in this region, this is a record strength ridge for the time of year that we're going to see Friday into Saturday. So therefore, it shouldn't be too surprising that we will probably see at least some record temperatures in this region, generally speaking, Friday into Saturday as well. While that's occurring, we are going to be experiencing some interesting weather conditions in Southern California because we have a nice low pressure system forming here. This broader pattern is known as a Rex block. So where we have the ridge up here, we have the low pressure system down here, we have the high up here, we have the flow moving generally in this direction at upper levels. So we have the air at mid levels and upper levels of the atmosphere going up and over the ridge and potentially through the ridge at the top of the ridge. But down here, what we've actually got is flow that at the lower levels especially, and also at the mid levels, that is almost in the reverse direction. So we have cyclonic flow down here, we have anticyclonic flow up here around the high pressure system. And so what's interesting, and this is a little bit confusing because the high and the low are closer to the surface, and this ridge is defined at a higher level of the atmosphere. So there's a little bit of, makes it a little bit confusing there. But so maybe I'll clear off the map and just reiterate that we have a low, we have a high, and around the low, the air is kind of going like this, and around the high is going like this. So what we've got in the middle here is a region that might be favorable for, if there's any subtropical moisture down in this region, to be advected across central and southern California. And in fact, that is what we expect to see as I toggle forward in time through the forecast, as this low pressure system slowly moves towards California over the weekend, southern California, and the ridge weakens as we get towards Sunday. This low pressure system drifts over southern California before being ejected eastward. But then it's replaced by essentially what I guess we could increasingly call, it looks a little more inside slidery than it did a couple days ago, but that was always a possibility. This low pressure system is sort of taking this kind of trajectory before it ejects eastward. It might cause a tornado outbreak in this region early next week. But for California and the Great Basin, what this probably means is a significant north wind event. So in this part of California, a pretty significant wind from north to south as this low pressure inside slider type system moves southward, and probably at least some Sierra Nevada showers. They may or may not be significant. We'll have to see. As that moves out later next week, it once again gets replaced by ridging, and perhaps not as extremely strong, although take a look at this. The subtropical ridge now down over Baja California becomes quite noticeably anomalous. We're starting to get back up into nearly 2 standard deviation territory. So this is actually quite strong subtropical ridging. You get subsident air, you get a really anomalously hot air mass in this region. So while it isn't directly centered over California, California does get some of the secondary ridging, and to the extent that we get any airflow from the south, it's going to be really, really hot as we go toward mid-June. And again, we see that this subtropical ridge signal persists in a quite strong fashion, with more diffuse, weaker, but still notable ridging across most of the west as we go all the way through mid-June. So this is sort of what temperatures might look like. Here's where we are today. Again, it's hot in Redding and in Bakersfield. It's not that hot yet in the Bay Area or coastal Southern California. But as we go into, say, tomorrow, this is the first big day. Well, actually, not even really the first big day. Hotter tomorrow in the Sacramento Valley than today and in parts of the Bay Area, but still not really near the peak. But then on Friday is when we really, really see some more extreme values. So those bright pinks and purples showing up. Again, this temperature scale is in degrees centigrade, so you multiply by about 1.8 degrees Fahrenheit to get your anomaly in degrees Fahrenheit. So essentially you can kind of eyeball it by multiplying by 2 and subtracting 20% or so. I know it's a bit of a weird heuristic, but we're talking about 15 to 20 degree Fahrenheit above average temperatures in the northern Sacramento Valley on Friday. And this is the region where we're most likely to see some record-breaking temperatures. Certainly daily records set, and maybe also getting close to monthly May records, which is notable. That's a significant event if we end up breaking any monthly records. As you can see, Southern California also hotter than average, including in some of the coastal valleys. So there's some heat advisories there, but not nearly as extreme as interior northern California. So hot, but manageable. Northern Sacramento Valley really is going to be very, very hot, right around 110 degrees in a lot of places. So probably won't reach 110 in Sacramento, probably closer to 102, 105 range around here. But Northern Valley, 110 is certainly possible, and that would be a monthly record for May in Redding, believe it or not. Even though Redding's a very hot place, hasn't been that hot in May. Has been certainly hotter than that in other months, but again, it is still May until Sunday. And also a broader region of pretty significant heat across the Great Basin in the interior west as well on Friday. And now we go into Saturday. You can see the most extreme axis of heat shifts inland. So now that's the Snake River Plain, the Great Basin, eastern Washington, eastern Oregon. Very hot on Saturday, probably daily to, again, possibly monthly records up in western Montana, Idaho, eastern Oregon, and another really hot day in the Central Valley. And so record heat all the way from potentially from Bakersfield to Redding. Probably not monthly record heat there, but maybe some more daily records. Hot in the Bay Area, away from the immediate beaches, but there might still be a bit of marine influence. We're not seeing as much offshore flow of this event as was originally suggested. So it'll be quite a beach day in Southern California, so it should be warm but not extremely hot at the beaches. It may even be relatively chilly still along the immediate beaches, but even places inland, Marin County, the East Bay, San Jose, could get well into the 90s and maybe even see some 100 pluses. So it'll be hot for sure. But then we go into Sunday, and there's the beginnings of a shifter here. So the coast gets a lot cooler. So the major cool down along the coast as onshore flow returns. Might still be pretty hot in Redding and Sacramento and Bakersfield. Warmer than average for May, certainly, but it will be cooler than Friday and Saturday as the pattern shift begins. And then once we get to Monday, huge change. Well below average temperatures across Southern California especially. Still seeing a bit of a pocket of anomalous warmth near Redding, Mount Shasta region, and I think this might actually be because this system has shifted from being a little bit more of a, we could have called it in days past, more of a coast hugger, sort of taking this trajectory, which might have been a bit wetter and cooler, but now taking a more of an inland trajectory and bringing north and northeast winds. So this is a warming downslope wind. We might not even really see that much of a cool down near, say, Redding early next week anymore. So the northern Sacramento Valley may remain warm, dry, and windy, though still cooler, as the rest of the state is much cooler and potentially sees some pretty strong winds. So as you can see, if you just compare, here we are on Tuesday, dramatic cooling, far below average temperatures across most of the west. Again, compare that to just a few days previous. It's a pretty dramatic shift as we go into next week. So, but as soon as we get back to Wednesday and Thursday, 7 days from now, take a look. Anomalous heat once again returns to the Central Valley. So again, this isn't just the usual, the Central Valley is warmer than the coast. This is saying that the Central Valley will be even warmer than it would usually be for early June. And potential for another heat wave thereafter. So I'll go to the smooth 5-day averages because this tells you a better picture when it comes to the ensemble. The heat signal re-emerging across California in our best performing European model ensemble. Nothing particularly extreme popping out right now, but again, pockets of pretty anomalous heat in the northern Sacramento and the southern San Joaquin Valley as part of a broader, unusually warm pattern. So we whiplash from potentially quite hot to much cooler, windy, and then quite hot again. And I also mentioned that there was potential, at least, for some interesting weather beyond temperatures, and so I'm going to back up, show you that now. Now I'm showing the deterministic run, not the ensemble, but just the single member of the ECMWF model for illustrative purposes. You can kind of see this weak low pressure system down here in Southern California kicking up a few isolated showers off the coast of Baja California in this prediction. But watch what happens as it inches closer to the coast. Well, actually, in this most recent model update, as always, you're seeing this live, it doesn't do too much. I take that back. I just wasn't far enough into the future. So as you go from late Saturday, you can see again, not a lot to show, but you can see these little blips of precipitation, including a few offshore. What this is indicative of is sort of a pattern of some potential elevated instability in the atmosphere. So you start to see it a little more over Baja California, and then a little bit more precipitation in the mountains, at least, as you go into Sunday, before this thing ejects to the eastward and potentially brings, as I mentioned, a tornado outbreak in this region. I'm going to back up a little bit. This doesn't look too impressive here. In fact, if you look at the total accumulated precipitation over this period, there is some in the mountains of far southern California, primarily down in by Julian and the mountains of San Diego County, for example, maybe a little bit farther north, and more significant down in Baja, but really not much to show for it over coastal southern California. Also a few showers over the southern Sierra. But there's a reason why this could be a little bit more interesting than it looks for the moment. And I'm going to use this kind of plot to show this. Again, here readily apparent is the low pressure system centered about here. You can see the swirling wind vectors like this in the middle levels of the atmosphere. And initially, it's entraining pretty dry air. That's low relative humidity air, like 30-40% relative humidity, nothing too impressive. But as we go into the weekend, again, this is mid-level humidity, you see that a slug of significantly moisture air, relatively higher relative humidity air, moves east to west across Southern California. This is the kind of pattern recognition tells us that even though the models aren't producing a huge amount of precipitation, there is at least some potential for some isolated thunderstorm activity, including outside of the mountains, I think, this weekend. So it wouldn't be totally outside the realm of possibility to get an isolated thunderstorm that makes it not just in the mountains, but maybe to San Diego or Los Angeles too at some point. This is a pretty moist atmosphere. We look at the relative anomalousness of the moistness of the air over the weekend, and it's pretty decent. We get some, especially over San Diego County, Imperial County in far southern California. Those are 3 to 4 standardized anomaly total column water. So again, don't be confused by the title of this plot here. The term precipitable water, it does not mean precipitation. So this is not a map of rain. This is actually, precipitable water means if you squeezed out all the water in the column of the air above your head, how much would precipitate. It doesn't mean that it's going to precipitate. In this case, the vast majority of it will not. But nonetheless, it's still a measure of the relative unusualness of how much moisture is there, and that's a pretty decent signal. Granted, it's confined to far southern California, so essentially the southeastern deserts and maybe as far as Orange or interior LA County. But that's a decent signal here. And if I switch over to the American model here, the GFS, which shows something similar for this period, I'll take a look. I actually don't know what this is going to show, if there's any surface-based instability. Not really, but again, in this case, what we'd really be looking for is elevated instability anyway, and so that wouldn't necessarily show up in this setting. But as that low-pressure system ejects eastward, and I'll show this again using our nifty relative humidity map. You can see as this low, the one that I've been talking about down here, watch as it goes inland. Take a look here where the secondary low comes down and sort of moves inland a bit. So actually I said it was a little bit of an inside slider. The operational model makes it a little bit less of an inside slider. You can see this coming down the coast. But look how dry that air is. I mean, there's almost zero relative humidity. Look at the scale down here. Less than 5% relative humidity in the center of this low. Despite having overwater trajectory, the coastline is here. This is a super dry, low pressure system. And you can see that the strong winds in the mid-levels of the atmosphere from north to south developing on that flank of the low. As this moves down, in this case, the operational model moves it down the coast. In the ensemble average is farther inland, but this is a possibility. But just look how dry that air is as it moves down the coast. It's bringing essentially clear skies and wind to the coast. and then dragging even drier air into California from the north afterward. So this is not a moist low pressure system. If I bring up the precipitation that's depicted here, again, you can kind of see, you see those surface pressure gradients. So you see those packed isobars, as they call them. That's my favorite term of the day, packed isobars. That's where these black curves are really close to each other. Well, each of these is a line of equal pressure. That's why it's called an isobar. Same pressure, essentially, is the source of that term. But look at the pressure gradient. So you can count, if you do a transect, count the number of bars that you cross when you go perpendicular to them. That's a very strong pressure gradient. Take a look at some other part of the country. For example, in this whole big region, you cross 3 of these isobars, and that's hundreds of miles. Here you go 300 miles and you cross, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So very strong surface pressure gradient. That's indicative usually of a strong pressure gradient force. And although I haven't looked at the map, I'm guessing that we're going to see very strong near surface winds. Aha, there we go. So these are 850 millibar winds, meaning the wind about 2,500 or so feet up above the surface of the ground. Those are near hurricane force winds. Howling north to south along the coast at about 2,000 feet up. So again, this is a very dry air mass with very strong winds. These are not at the surface, so we're not going to get hurricane force winds at the surface, but it's an indication of very strong winds aloft. If I take a look at the surface winds, those will probably be pretty strong, but weaker. There we go. So here is the actual projected surface wind for next Monday. Again, over the ocean, west of the north coast, those are 30 to 45 mile an hour sustained dry north winds over the water. So that's nothing to sneeze at. And then as the system moves inland, you can kind of see that although they're not super strong, the winds start to pick up over the interior of California next week too. This could pose a fire weather threat because it will follow a significant heat wave. So even though it will be cooler, dry and windy, it will be cooler, dry and windy following a significant heat wave. So in grass and brush regions, elevated fire weather is quite likely. Early next week, we might even see some red flag warnings. These will not be extreme fire weather conditions compared to what we can see during peak season because the vegetation is not that dry yet, and these winds will not be as extreme as what we can see in late summer or fall in this region, but it will definitely elevate the likelihood of grass fires and brush fires, and as you know, wind-driven grass or brush fire, even when it doesn't occur in peak season, can cause problems if it occurs at the wrong place at the wrong time. I wonder if the American model has even stronger winds. Yes, there we go. That get a little bit farther inland. So that's the general gist of things here. Looking forward, just in terms of places that might experience some record warmth. This is the current Weather Service prediction for places that will either break or tie records. This is for Friday, so Sacramento, Ukiah, so Lake County, the Sacramento Valley, Redding, all of these regions. A couple of points in the inland valleys of Southern California. Reno at 96, that's really pretty hot for May, so that'll be probably a record. And then Saturday is the day where we actually see probably the most number of temperature records, although more of them will be inland, as I mentioned, sort of in the swath. But we could see records in the San Joaquin Valley, 105, Fresno, Bakersfield, Merced. Reno, 99 degrees maybe on Saturday. That is awfully hot for late May. Northeastern California up in the 90s, and it'll still be hot in this region, just might not reach quite the same record levels, but again, producing pretty significant snowmelt. As we often see these days, even places that don't see record daytime temperatures may well see record warm overnight temperatures, and that includes places in Southern California and places along the coast and places in the mountains. This is, I believe that's South Lake Tahoe with a record warm overnight temperature of 56 degrees, meaning that over the weekend, even at South Lake Tahoe elevation, it might not get colder than the mid-50s. This is why I expect much of what remains of the snowpack to do a pretty quick poof in many regions this weekend across the west. Okay, so I'm going to go back and bring my screen back up. You'll see me talking, and I can answer some questions. All right, folks. So now I'm in the Q&A phase of the live stream, and feel free to add your questions now. It's a good opportunity. There aren't too many live questions today, so your odds of being answered are higher than average. So I'm going to start at the beginning, as I usually do. Some question about, is the upper 80s normal for Canada this early in the season? Well, that depends entirely on where you're talking about. If you're talking about Nunavut, no. If you're talking about the plains in Alberta, it can certainly get that hot or hotter even this time of year, so it really depends on where you are. I will say that Canada has been having yet another very severe start to fire season. So there have been whole towns evacuated. There's been quite a bit of destruction and even death, unfortunately, up in Canada with the early start of fire season. Now, fire season does start in Canada somewhat counterintuitively earlier than it does across a lot of the American West. Despite being further north, the boreal forests in Canada reach peak seasonal dryness in mid-spring in many places. It varies a bit depending on where you are, but those conifers, it's that window between when you lose the winter snowpack, that's gone on the ground, but before the seasonal green up of the grasses and moisture uptake of the evergreen needled trees, they tend to experience their most flammable conditions often in terms of moisture levels in a typical year in late spring. So May is the month, if there's going to be really big fires that get going in the early season in parts of the boreal forest, May is when they're going to happen. Unfortunately, this year that's happening in spades. Now, the problem is, as we've seen in recent years, it used to be that there'd be this narrow window, 2 to 6 weeks long, when you could get these big fires in the boreal forest. But increasingly in recent years, we've seen in Canada that those really intense dry conditions are now being sustained for much of the summer and even into the autumn. And unfortunately, the seasonal outlook very much supports a worsening of drought and fire conditions up there the rest of summer. So this could be yet another banner year for something we don't want to see, which is very high fire activity in Canada, and this year potentially also in the forests of western United States. And that's something we haven't seen in recent years, so there's been a bit of a trade-off. At least this is not a good year to be seeing both active at once for any number of reasons, resource-wise and otherwise, and that very well is somewhere where we may be headed. All right, here, let's see. The question is, the whole northern hemisphere going to be above average this summer? Well, if we're talking about temperatures or geopotential heights, which are a measure of the aggregate warmth of the lower half of the atmosphere, for example, if we're talking about the 500 millibar geopotential height, yes. There's unlikely to be any part of the northern hemisphere that is meaningfully below average, and many places will once again experience record warmth. In fact, the European Climate Consortium that has been producing more climate change predictions recently, as the U.S. steps away from offering those kinds of services and perspectives, just put out a recent report on the sort of the short-term climate projections. So the next 5 years or so, we can't predict precipitation patterns out that far. We just don't have the ability. But at global scale, we have some skill of predicting the short to medium-term trajectory of temperature. And it was expected that, in fact, we will likely experience at least one more record warm year. So despite the fact that each of the last 3 years have been near record or record warm globally, and there had been some expectation that this might significantly, briefly plateau at least, as the natural cycles went out of alignment with the long-term warming trend caused by humans. Unfortunately, it does not really appear that there's going to be much of a pause this time, and we're just going to keep ratcheting it up and up and up and up. And it won't be record warm every year, but there's very high likelihood, like 80 to 90% chance, that we'll have yet another record warm global temperature year in the next 5 years. Could be, there's a decent chance it won't be this year, but very high chance that it will happen in the following 4 years once again. So we're not seeing as much of a plateau. We are seeing every summer now, it's quite likely that large swaths in the northern hemisphere will experience record-breaking temperatures. That is the pace of the warming that we're seeing right now, such that most years, significant regions see new periods of record warmth. Might not be the same patch of the northern hemisphere every year, but on average, yes. The short answer is absolutely yes. And the western U.S. and Canada, and central U.S. as well, by the way, are candidates for being one of the places in the northern hemisphere this summer that experience record warmth, not just highly anomalous warmth. All right, here, let's see what we got. The question about Darius asks, this summer is going to be above average per the predictions, at least, that I've just been talking about. But there have been summers where we've been well below average, and how does that happen? Well, part of it is just that it didn't take so much previously to have a cooler than average summer. If your climate isn't warming rapidly, then in any given decade or 20 or 30 year period, you're going to randomly have some years that are a lot warmer or cooler than other years. That's just sort of how random climate variability works. Some of it is truly random, just year-to-year variations that are unpredictable, and some of them are going to be related to semi-predictable ocean atmosphere variations, the El Nino Southern Oscillation cycle, which is a true cycle, the Pacific Decadal Oscillation, which may or may not be a true cycle, but it certainly exists to the extent that it means that there's decadal, multi-decadal variability. So there's just these natural inherent swings between wetter and cooler, cooler and warmer states in the ocean, which translate to a certain extent to the atmosphere, especially in places that are close to an ocean like California. But the problem is, these days, a rising tide lifts all boats. And so what it means is that the natural variability is still there. We still swing from warmer to cooler relative to the recent baseline. But because we're on an escalator going up, those swings between wetter and drier, cooler and, I'm mixing my atmospheric variables. Between warmer and cooler, aren't as noticeable, at least in the longer term anymore, because the long-term trend is just warmer, warmer, warmer. Doesn't mean every single year is warmer than the past. Doesn't mean that every decade even is necessarily, at least at local scales, warmer than the past. And as I've emphasized in some recent sessions and blog posts, we haven't seen that much recent warming in spring in California, for example. So we have kind of flatlined in spring in California. Now the opposite is true in summer. We've just really roared forward to hotter and hotter summers, but spring's not so much. Now, spring is still warmer on average than it used to be in California, but that's because a lot of the warming in spring, specifically in California, occurred prior to the year 2010. So the last 15 years or so are much warmer than the 20th century almost all the time, but the last 5 years are not really any warmer than the previous 10 in the spring in California. So that's an example of how natural variability still can superimpose on that long-term warming trend and sort of temporarily mask things. In summer, I think the opposite has happened. We've probably had some natural variability that's resulted in even faster than expected warming in summer. So we have the global warming, the human-caused climate change part, and then we probably also have on top of that some natural variation that was pushing us towards warmer conditions as well. So there, the human signal and the natural signal are in alignment. They're both going in the same direction. In spring recently, it seems like the human signal is, of course, still towards warming, but the natural cycle recently has been towards a little bit of cooling. Now the problem is, in the long run, the natural cycles kind of wash out. You get some warming, you get some cooling over time, you stay pretty close to where you were. But you add those wiggles on top of a long-term trend that's just in one direction only, and what you end up getting is sort of a wiggle on an upward trajectory that just sort of stair steps upward. So I did get a comment from one person that the video stream is very blurry. Now, I don't know. I don't see that on my end. I do see that the background lighting has shifted a bit. It got much darker because the sun went behind a cloud, so my auto lighting, it was set for the beginning of the session, and now it's maybe a little bit overexposed. But I don't see that it's blurry. I do see that it looks like it's in focus to me. So let me know if that maybe was a comment from earlier. Maybe it was blurry earlier, but always helpful. There's a question from Marty that I'm going to probably defer to another section about how vegetation conditions like ERC, they're the energy release component, and the BI or the burning index are used with weather conditions to predict wildfire risk. I might reserve that for a little more wildfire focused session. I'm sure we'll have plenty of those this year. Question about any idea on the monsoon activity in the Southwest later this summer. Again, a reminder that the wet season in some parts of the desert Southwest is in fact from July through September, when there's a seasonal reversal in the winds, which is what a monsoon is, by the way. The monsoon is a reversal in winds. It is not a downpour or a storm. It is a wind pattern specifically. That reversal in winds, which usually begins in July in the Southwest and brings afternoon thunderstorms that can bring a lot of water all at once, but in kind of a scattered fashion. Right now, there's not much of a signal either way, so there is no reason to believe it will be a particularly dry monsoon. So if you're rooting for a good monsoon year, you have decent odds because there's no real predictive signal pointing in a particularly dry direction. Not necessarily a very strong signal in a wet direction either, but to be quite honest, we do not have great seasonal predictability of the monsoon precipitation, so I would say that anything short of a very strong indication of wet or dry pretty much tells us it's kind of 50-50, which recently, and those aren't bad odds. So could be a decent year, might not be, but there's no particular reason right now to think the signal will go either way. It does point to a particularly hot monsoon season in general because the whole West looks hotter than average. So there is that, but that can be somewhat uncoupled from the monsoon precipitation. So right now we just don't know. Are there any indications yet? HJ asks whether we'll tip into El Nino or La Nina this fall, or too early to tell. There are, unless there was an exceptionally strong signal, which there is not at present, it is too early to tell. If all of the models were screaming El Nino or La Nina and very strong one in either direction right now, I might talk about it a bit more, but right now there's just not much of a signal toward either. There might be a slight tilt, but it's pretty meaningless at this time scale with that weak of a signal. So another situation where right now we are not in a window of predictability with respect to ENSO. Sometimes, if there's a very strong one that looks like it's on the horizon in either direction, we might be able to say something, but right now there does not appear to be, and so can't say much about it. So I think we will probably have to be more opportunistic about taking those windows of predictability and leveraging them, and also acknowledging when we're not in them, like I think is the case right now. With everything except for summer temperature across the interior West, there is a very strong signal still in the ensemble average for a very hot summer across the interior western portion of North America, both US and Canada. All right. One thing I'm going to do at this point is to reshare that link, now that I'm about to wrap up my session, to the 100-hour-long, staffed by dozens and dozens of my weather and climate colleagues live stream that is really just aimed at showcasing the value of weather and climate science and practice, and again, practice being operational meteorology, day-to-day weather prediction, so not just the research, but where you get your day-to-day information from, and talking about why it's at risk, what is potentially lost if it is greatly diminished, as we are on a path to do right now, what we can potentially do to save it in this moment, and also just to sort of remind folks that scientists are people too, and that's one of the things I try and do on these live streams. By the way, it's one of the reasons why I do prefer the informal format, and it's also why I'm going to be offering an off-the-cuff Ask Me Anything style session as part of this event on Saturday evening. Again, my contribution will be at 6:30 p.m. Pacific time on the live stream link I just posted in the chat. That live stream is already underway, and the keynote talks for tonight are also underway. And in fact, I may go tune in myself because folks like Carrie Emanuel and Adam Sobel, if you're in the weather and climate world, you may recognize their names if you're interested in things like hurricanes or extreme weather. Lots of other folks. Jeff Masters from the Weather Underground will be there later. I believe that may be this evening, talking about his experience in the hurricane hunting aircraft in the 1980s, and how his last experience on one of those flights was almost the last experience of everybody on that flight. If you want to hear that story, among others, I really do think this is an event that is both really worth turning into for anybody who's interested in weather, climate, wildfire, or science in general in the United States. And I suspect that really anybody who tunes into my Weather West live streams will likely be very interested in what the folks on this one have to say. So we have 100 hours to tune in. The prime time hours are the ones where there's the most organized and highest profile talks. Tonight, tomorrow, Friday, Saturday, and also Sunday. And again, it's a continuous 100-hour long live stream. So strongly encourage folks to join over there. I'm going to go watch myself. You can also catch me Saturday evening. The schedule's available at the link. So thanks for joining, as always, and I will see you next time, and potentially see you on Saturday evening with a slightly broader national audience, I believe, than sometimes the California and Western-centric audience on Weather West. So see you then.